everybody. Myself, Yeldos P. Jacob, Assistant Professor Chemistry, Department of Science and Humanities. As we all know that we belongs to Abdul Kalam Technological University. For the first year students, it is mandatory that you all should learn engineering chemistry. So this is my first video which explain the first module of 2019 syllabus for the KTU first year students for the subject engineering chemistry. All the classes are based on some specific course outcomes. So in this video, I will explain the course outcomes and some basics of the first module. So let us move to that. So the name of the first module is Electrochemistry and Corrosion. From the terms, I think that from the terms it's clear what are the topics. You can guess what are the topics belongs to this module. If you read the course outcome, it depicts like this. The main reason or the main outcome which we expected from you all that to apply the basic concepts of electrochemistry and corrosion to explore its possible applications in various engineering fields. So just study. Oh, this is the module is to introduce the and study and apply the basic concepts of electrochemistry, and corrosion to explore the possible applications of in engineering field. Okay, so the first term in the syllabus is electrochemistry. What do you mean by electrochemistry? It's very simple. I think that for the state and CBSE students, your third chapter is in your +2 or higher secondary second year is electrochemistry. Then tell me what you mean by an electrochemistry, or what are the topics belongs to electrochemistry? Any idea? As a teacher, I wish to dissect this word into two, and the dissection is like this. I got two terms. The two terms are, so the two terms, yeah, I got electro and chemistry. So when you combining these two terms, I can say that this is a branch of chemistry, or it's a section of chemistry which depends upon or which deals about electro. What do you mean by electro? A number of interpretations can be given for that, the term electro. Electro can be termed or read like electricity or electrons. So mainly these are the two concepts or the two ideas which deals in this particular module. Did you got it? Yes. So by the definition, it's clear that electrochemistry is a branch of chemistry. There is no doubt about that. That deals with the chemical changes. Just study the term. It deals about the chemical changes produced by electricity and production of electricity by chemical change, which means mainly this chapter deals about electricity, or how it is produced, and how the chemical reactions or the chemical changes carried out using electricity. Simple ആയിട്ട് പറയുകയാണെങ്കിൽ chemical energy ഉപയോഗിച്ചിട്ട് electrical energy produce ചെയ്യുന്നതും electrical energy use ചെയ്തിട്ട് chemical energy produce ചെയ്യുന്നതും. See, these are the two main topics we are dealing in this module. You got it? I think I hope you clear that. It's clear. If you move to the next stage or the next stage, before we are entering into the module, let us familiarize some terminologies or the main terms which we daily deal. So let us move to that. The first term is electrode. I think that you know what you mean by that. Electrodes are the vital component of an electrochemical cells where current enters and leaves the electrons. Once again, electrodes are the vital components of electrochemical cells where current enters and leaves. That's it. So it's a vital component or the vital part or the main component. Here the transfer of electrons or the current is being happen. The next term is electrolyte. We know what you mean by electrolyte. An electrolyte is a substance that produces an electricity, produces an electrically conducting solution when it is dissolved in a polar solvent such as water. That's the main definition. We cannot say that all the components which is dissolved in water or solvent cannot be act as an electrolyte. There is a criteria for be an electrolyte. The condition is if X is a compound, if it is said to be an electrolyte, it should produce electrically conducting solution or it have a capability to conduct electricity. That's the main condition. Oh, that kind of solutions are termed as electrolyte. And the dissolved electrolyte separates in mainly into cations and ions because they are the carriers of electrons or the electricity. The next terms which we discuss is salt bridge. We will discuss the term in detail in the next slides. Just go through the definition. It's clear that it's a laboratory device used to connect the oxidation and reduction half cells of galvanic cell to complete the circuits or to provide charge balance. Just it's a bridge. Bridge means it will connect two things. So what are the things we connect is the half cells. We will discuss what even by half cells in the next slides. So just make a quick review on that. Next term is we discuss the main two terms, anode and cathode. I think that most of the slides or most of the topics, the main basic is these two terms, anode and cathode. Without introduction, you know what are that. What are they? Anode is the half cell at which oxidation occurs. The main point is these are the cells at which oxidation occurs. And cathode at the cell at which reduction occurs. Just keep it in mind. Anode will give oxidation and that of cathode it will produce or it undergo reduction. That's it. But the point. So then you have a doubt, sir. You discuss anode and cathode, and we know that anode is the cell at which oxidation occurs, and cathode is the cell at which reduction occurs. So maybe there is a doubt, maybe rise. What do you mean by this oxidation or reduction? Let us move to that. Oxidation, first of all, we have to define what I mean by oxidation. Then the oxidation and reductions are the just opposite terms. If you gone through one topic, then it will be the next topic can easily we can repeat it, which is just opposite to that. So first of all, just go through that oxidation. Years and ago, they define that from the term oxidation, it consists of oxy, which means there is something depends upon oxygen. Years and years ago, the ancestors believed that oxidation is the process at which the gaining of oxygen occurs. When at the same time the reduction is take place, or reduction is defined as the losing gaining of hydrogen, because they are opposite, because oxygen and hydrogen, they are the main vital components. So oxygen, just keep it in mind, its oxygen is the gaining, oxidation is the gaining of oxygen. Then it's another definition is for that releasing of hydrogen. Just keep it, just study the topics oxidation, then we can easily you can write the points of reduction, because it's just opposite. Next is it's gaining of, we know that oxygen is an electronegative atom, then the studies revealed that not only the oxygen, if any electronegative atom is gaining in a reaction, we can see that it can be considered as an oxidation reaction. Then what will be the next one? The second point, say, releasing of hydrogen can be termed as oxidation. Hydrogen is an oxidation, sorry, electropositive atom. So similarly, we can say that the next point, releasing of electropositive atom can be termed as oxidation. And finally, the most sophisticated, or the latest, not sophisticated, the latest invention or the concept is releasing of electrons. If in a reaction some electrons are being released, if in a particular reaction I can write it as if this is an oxidation reaction, yes, okay, just that is zinc gives Zn2 plus 2 electron, Zn2 plus 2 electron. Here the electrons are released, we can consider that this is an example for oxidation. Then reduction is the definition just opposite. If the gaining of oxygen is oxidation, then here gaining of hydrogen. Releasing of hydrogen, releasing of oxygen. Gaining of electronegative atom, gaining of electropositive atom. Releasing of electropositive atom, here electronegative, just opposite to that. I think that you all are familiar with this in your high secondary classes. Let us move to the next one, is the first topic. I think that some of the question papers, if you check the question papers, you can see this question mention any some applications or some differences between electrochemical cells and electrolytic cells. Just gone through that. Electrochemical cells, electrochemical cell convert the chemical energy into electrical energy. What about this electrolytic? Just opposite. What is here? Chemical is converted to electrical energy, but here the electrical energy is converted to chemical energy. Second point is based on redox reactions which are spontaneous. Spontaneous means a reaction which taking place without any influence of any other external sources. But here the electrical energy is converted to chemical energy, that is electrolytic cell, which means the electrical energy is facilitated to take place the non-spontaneous chemical reactions. That's why the electrical energy is converted to chemical energy. So here we can see that the point can be written as the redox reactions are non-spontaneous in nature, only when energy is supplied. And the third point is chemical energy changes occur in two beakers are different, and only one chemical component undergo decomposition. That is another thing. Then here the anode is negative, oxidation is taking place. Here anode is positive. Every time this oxidation is take place at anode. So this point is not relevant, but we can try it. The main difference is in electrochemical anode is negative, electrolytic anode is positive. Then what will be the next point? Cathode have the positive value in electrochemical cell, but that about in electrolytic cell it's of negative value. Okay. Yes. Next, let us discuss what you mean by a galvanic cell or an Electrolyte cell. In a galvanic cell, a redox reaction is used for what? To convert the chemical energy into electrical energy. That's the main point. The driving force for the production of electrical energy in a galvanic cell is a redox reaction. What do you mean by redox reaction? Yeah, redox. It can be split like this. How? We can split like this: red plus ox. Red stands for reduction and ox stands for oxidation. If reduction and oxidation reactions take place simultaneously in a system somewhere, we didn't care. That type of system is known as redox system. In a galvanic cell or in voltaic cell, the basic reaction is this redox reaction, which means one part undergo oxidation and another part undergo reduction. How? This oxidation reaction release some electrons and the reduction species absorb that electrons produced by the oxidation compartment. So there is a transfer of electrons. What do we mean by the transfer of electrons? Simple, that is electrical energy. So we can see that in electrical energy and in a galvanic cell, the redox reaction is used for the conversion of chemical energy into electrical energy. The next point is each compartment consists of a suitable electrolyte solution and a metallic conductor. I think that before you discussing this about this galvanic cell, you know the best example for a galvanic cell, that is Daniel cell. We will explain this in the coming classes. What I mean by Daniel cell means there are two beakers, and the first beaker consists of this zinc sulfate solution, and there is a zinc rod, and the next will consist of there is a copper solution, and which is dipped in copper, and they are connected, and there is a salt bridge is placed between that. This is known as Daniel cell. So this is an example for a galvanic cell. So what are the components? Yeah, there are two components for there. These are the two components. This is one component and this is one another component or compartment. Each compartment consists of suitable electrolyte solution and a metallic conductor. You can see there is a metallic conductor is there. This is the metallic conductor and there is an electrolyte is there. Okay. The next one is metallic conductor act as the electrode. You know what you mean by that. And the compartment containing the electrode and the solution are known as the very important point. They are known as half cells. Then in the coming days or the coming slide, I will explain. I will tremendously in number of times I will use the term half cells. Just keep it in your mind. Half cell is a combination of electrode and an electrolyte. Okay. Yes. The two compartments are connected by a salt bridge, and an electrodes are joining using by a wire through a galvanometer. I think that you know all these. Then the electricity begins to flow from anode to cathode. Why anode to cathode, not from cathode to anode? The reason is anode produce electricity, cathode accept electrons. Sorry, anode produce electrons and cathode accept electrons. Ready? The simple example for form of galvanic cell is Daniel cell that I drawn on the top. Galvanic cell representation is represented below. Anode electrode bar ion in the solution, or ion bar double bar. This double bar indicates what indicates this double bar? This double bar indicates salt bridge. This is salt bridge. This is salt bridge. This is salt bridge. And this ions in solution. So first of all, you have to write about anode. Then you have to write about cathode. When you're dealing about anode, first you have to write the electrode. First of all, you have to write the electrode. Then you have to write solution. In case of cathode, first is solution or ion, then electrode. Okay. Let us discuss what you mean by a Daniel cell. Daniel cell, this is a representation, or this is the pictorial representation of Daniel cell. You can see that there is a zinc sulfate solution. To that there is a single rod is dipped, which is kept on the left side. And the copper sulfate solution, to that there is a copper solution. Copper rod is dipped, which is placed on the right side. And they're both the compartments, or both the half cells are connected using a U-shaped tube, which is known as the salt bridge. You got it? You can see that what you mean by a salt bridge. You can see there is a salt bridge is present here. With the help of these, all the electrical energy will begin to flow. So we know that Daniel cell is a typical example of galvanic cell. It consists of a zinc rod, which is dipped in zinc solution, and copper rod dipped in copper sulfate solution. The two metal rods are connected through a voltmeter, and the two solutions are connected through a salt bridge. Okay. And then about Daniel cell, the electrode at which oxidation occur is anode. We know that point is anode, and the electrode at which reduction taking place at cathode. Here, anode is zinc, and that of cathode is copper. We will explain why this, because it depends upon the term oxidation potential, reduction potential. We will discuss on the next slides. So we can say that always the electrons should be flow from anode to cathode. Why? Because anode is the cell or the compartment at which oxidation taking place. Oxidation means the flow, releasing of electrons. Releasing of electrons. Which means this anode release electrons. And the cathode cathode accept electrons. That is the main difference between them. Okay. Yes. Let us move to the next. So we can say that the movement of electrons is always from zinc to copper, which produce an electrical current in external circuit. Next topic is Daniel cell reactions. And zinc, we know that zinc is the anode, so which undergo this oxidation reaction. So we can write its Zn gives Zn2 plus 2 electrons. Why? The Zn2 plus is stable because it's 3d10 configuration. We know these concepts. And the copper 2 plus undergo this by accepting 2 electrons, and they undergo metal state, that is copper 0 in state, and it's reduced to copper metal, and the reaction can be represented Cu2 plus 2 electrons. So the overall cell reactions can be written like this: Zn plus Cu2 plus give Zn2 plus Cu, because just add these both equations. Just cut the common terms, that is 2 electron is common here and here, so we can cut it. So LHS എല്ലാം ചേർത്ത് എഴുതി, here the LHS is Zn, here the LHS is Cu2 plus. Then put the arrow mark, here Zn2 plus is on ones and Cu2 plus is 2. So this is the representation. So the cell representation, we can say that here the anode is zinc. When you write this cell representation, anode എന്ന് പറയുമ്പോൾ നമ്മൾ ആദ്യം എഴുതുന്നത് അതിൻ്റെ മെറ്റലാണ് Zn bar, and a solution ZnSO4. In some books they prefer to use these metal ions only. ഏത് എഴുതിയാലും കുഴപ്പമില്ല. Here I am using the complete, or I am just 2 plus തന്നെ എഴുതുകയാണ്. 2 plus there is a salt bridge is present. Next of cathode എഴുതുമ്പോൾ ആദ്യം solution എഴുതണം, that is Cu2 plus solution bar Co. So this is the cell representation, and that of the cell representation, EMF of the cell is 1.1 volt. Okay. So next is salt bridge. We know what I mean by a salt bridge. Salt bridge and its functions. Salt bridge is usually an inverted U-tube filled with gelatin or agar-agar, which is saturated with concentrated solution, which is filled with saturated concentrated or saturated with concentrated solution of inert electrolyte. എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ഇതൊരു യു ഷേപ്പ്ഡ് ട്യൂബാണ്. അത് ഫില്ല് ചെയ്ത് വെച്ചിരിക്കുന്നത് രണ്ട് സാധനങ്ങളാണ്, ഒന്നെങ്കിൽ അഗാർ അഗാർ അല്ലെങ്കിൽ ജലാറ്റിനും, പിന്നെ ഏതെങ്കിലും ഒരു ഇനേർട്ട് ഇലക്ട്രോലൈറ്റ് വെച്ചിട്ടുള്ള ഒരു സൊല്യൂഷൻ കൂടി ചേർത്ത് വെച്ചു. നോർമലി നമ്മൾ യൂസ് ചെയ്യുന്ന ഇലക്ട്രോലൈറ്റ് അല്ലെങ്കിൽ സോൾട്ട് എന്ന് പറയുന്നത് KCl, KNO3, NH4NO3 എന്നിവയാണ്. Just അത്ര ഓർത്ത് വെക്കുക. It is a U-shaped tube which is filled with agar-agar or gelatin with saturated, concentrated, highly concentrated inert electrolyte. Okay. What are the functions? Let us discuss. The first one is it completes the electrical circuit. Just gone through the main points. It completes the electrical circuits by allowing pass the ions from one solution to other without mixing the two solutions. Next point is it maintain the electrical neutrality. The second point is it maintain the electrical neutrality. And the third point is it eliminate the liquid junction potential, the potential difference between the junctions of two solutions of electrolytes when these are in direct contact with each other is known as liquid junction potential. നിങ്ങൾ നിങ്ങളുടെ +2 അഞ്ചാമത്തെ ചാപ്റ്റർ, ദാറ്റ് സർഫസ് കെമിസ്ട്രിയിൽ രണ്ട് സൊല്യൂഷൻസ് ചേർന്ന് വരുമ്പോൾ ആ ജംഗ്ഷൻ ഉണ്ടാവുന്ന പൊട്ടൻഷ്യലാണ് ലിക്വിഡ് ജംഗ്ഷൻ പൊട്ടൻഷ്യൽ എന്ന് പറയുന്നത്. So 3 of the functions. First one is complete the electrical circuit, second one electrical neutrality, third one is eliminate liquid junction potential. Let us discuss what I mean by single electrode potential. Single electrode potential. Potential means ability. The ability of a single electrode is known as single electrode potential. It is mainly explained using this. When a metal rod is in contact with a solution of its own salt, it may undergo either oxidation or reduction depending upon the nature. എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ നമ്മളൊരു സൊല്യൂഷൻ എടുത്തിട്ട് ആ സൊല്യൂഷനിലേക്ക് നമ്മളൊരു ഇലക്ട്രോഡ് മുക്കി വെച്ച് കഴിഞ്ഞാൽ മേ ബി ഇറ്റ് അണ്ടർഗോ റിഡക്ഷൻ ഓർ ഓക്സിഡേഷൻ. ദാറ്റ് ഡിപ്പെൻഡ്സ് അപ്പോൺ ദ സർക്കംസ്റ്റാൻസസ്. ഓക്കെ. സോ ഡ്യൂ ടു ദിസ് ഏതർ പോസിറ്റീവ്, ഇപ്പം നമ്മൾ ഓക്സിഡേഷൻ ആണ് നടക്കുന്നതെങ്കിൽ എന്ത് സംഭവിക്കും? മെറ്റലിൻ്റെ ഇലക്ട്രോഡിന് പോസിറ്റീവ് ചാർജ് വരും, നെഗറ്റീവ് ചാർജ് വരും. കാരണം എന്താണ്? ഈ സിങ്ക് 2+ ആയി കഴിയുന്ന സമയത്ത്, ഇപ്പോൾ സിങ്ക് എടുക്കുകയാണെങ്കിൽ സിങ്ക് 2+ ആയി കഴിയുന്ന സമയത്ത് രണ്ട് ഇലക്ട്രോണെ കളഞ്ഞിട്ട്, ഈ കളയുക എന്ന് പറഞ്ഞാൽ ഇലക്ട്രോഡ് അക്സെപ്റ്റ് ചെയ്തിട്ട് Zn2+ ആയിട്ടുള്ള സൊല്യൂഷൻ അയോൺസ് സൊല്യൂഷനിലേക്ക് പോകും. അപ്പോൾ ഓക്സിഡേഷൻ നടന്ന നെഗറ്റീവ് വരും, മറ്റേ റിഡക്ഷൻ നടന്നു കഴിഞ്ഞാൽ പോസിറ്റീവ്. ദാറ്റ് ഡിപ്പെൻഡ്സ് അപ്പോൺ ദ സർക്കംസ്റ്റാൻസസ്. This results the formation of a layer of positive or negative charge around the metal. This is called chemicals. എന്ന് പറഞ്ഞാൽ നിങ്ങൾ ജസ്റ്റ് സങ്കല്പിക്കുക, ഇപ്പോൾ ഇവിടെ ഏതെങ്കിലും റിയാക്ഷൻ നടന്നു കഴിഞ്ഞാൽ എന്ത് പറ്റുമെന്ന് അറിയാമോ? there is a charge is accumulated. ഇപ്പോൾ ഇവിടെ ഞാൻ കാണിച്ചിരിക്കുന്നത് ഓക്സിഡേഷൻ നടന്നു കഴിഞ്ഞപ്പോൾ ഇവിടെ സൈഡിൽ മൊത്തം ഇവിടെ നിന്ന് മുതൽ താഴെ വരെ you can see that there is negative charges. ഈ നെഗറ്റീവ് ചാർജ് ഇവിടെ വരുമ്പോൾ you know that opposite charges attract each other. അങ്ങനെ വരുന്ന സമയത്ത് ഇതൊരു ലെയർ, we can see there are two double layers. These are known as Helmholtz electrical double layer. Okay, due to this formation of layer, a potential difference is set up between the metal and the solution, which prevent further exchange of ions between metal and solution. കുറേ നേരം ഇങ്ങനെ ഇത് ഫോം ചെയ്ത് കഴിയുമ്പോൾ നമുക്ക് പറയാൻ പറ്റും ആ ഒരു ട്രാൻസ്ഫറിന് ഒരു പ്രിവെൻഷൻ വരും. There is a potential differences. There is a potential. At equilibrium, the potential difference between the metal and the solution become a constant value and which is known as electrode potential of എന്ന് പറയുമ്പോൾ ആദ്യം കുറേ നേരം അങ്ങോട്ടേക്ക് പോകും അല്ലെങ്കിൽ ഇങ്ങോട്ടേക്ക് വരും എന്ന് പറഞ്ഞാൽ രണ്ട് സ്ഥലത്തേക്ക് മേ ബി ഈ ഒരു മെറ്റൽ അയോൺ ആകുന്നു അല്ലെങ്കിൽ മെറ്റൽ അയോൺ ഇതായിട്ട് മാറുന്നു. സംടൈംസ് ഇത് ഇങ്ങനെ നടന്നു കഴിയുമ്പോൾ ആഫ്റ്റർ സം ടൈം ഇറ്റ് അക്വയർ ആൻ ഇക്വിലിബ്രിയം. ദ പൊട്ടൻഷ്യൽ അറ്റ് ദ ഇക്വിലിബ്രിയം ഈസ് നോൺ ആസ് ദ ഇലക്ട്രോഡ് പൊട്ടൻഷ്യൽ എന്ന് പറയാം. So it measures the tendency of metallic electrode to lose or gain electrons when it is in contact with a solution of its own ion of unit molar concentration. That is, the tendency to lose electrons is known as oxidation potential, and the tendency to gain electrons is known as reduction potential. That's the main point. Tendency to lose electrons is known as oxidation potential, and the tendency to lose gain electrons is known as reduction potential. Then the next and the last topic is EMF, or electromotive force, which is also known as cell potential. Let us first of all discuss the topics. Electromotive force is the driving force that arises from a difference of potential which causes an electrical current to flow from one electrode at a higher potential to other electrode at a lower potential is known as electromotive force. Electromotive force is a force. EMF എന്ന് പറഞ്ഞാൽ അതൊരു ഫോഴ്സ് ആണ്. എവിടെ നിന്നാണ് അത് അറൈസ് ചെയ്യുന്നത്? ഇറ്റ് അറൈസസ് ഫ്രം ദ ഡിഫറൻസ് ഓഫ് പൊട്ടൻഷ്യൽ. ഓരോ ഇലക്ട്രോഡിന് ഇപ്പോൾ നമ്മൾ പറഞ്ഞ പോലെ തന്നെ ഓരോ പൊട്ടൻഷ്യൽ ഉണ്ട്. എവറി ഇലക്ട്രോഡ് ഹാസ് എ പൊട്ടൻഷ്യൽ ഫോർ അണ്ടർഗോ ഓക്സിഡേഷൻ ഓർ ഇറ്റ്സ് അണ്ടർഗോ റിഡക്ഷൻ. ഡ്യൂ ടു ദിസ് ഡിഫറൻസ് ഇൻ പൊട്ടൻഷ്യൽ ഓഫ് എനിത്തിങ്, or if you're dealing about reduction potential, or that is ആ ഒരു ഇതിനാണ് വിളിക്കുന്നത്, which cause an electrical current to flow from one electrode at a higher potential to other electrode at a lower potential. ആ ഫ്ലോ ചെയ്യുന്നതിന് ആവശ്യമായിട്ടുള്ള ഡ്രൈവിംഗ് ഫോഴ്സ് ആണ് ഇതെന്ന് പറയുന്നത്. And its unit is volts, and there is a equation is known as that E cell is equal to E right minus E left, that is E cathode minus E anode. Why E right minus E left? എപ്പോഴും കാഥോഡ്, ഇപ്പോൾ മെയിൻലി വി ആർ ഡീലിംഗ് അബൌട്ട് റിഡക്ഷൻ പൊട്ടൻഷ്യൽസ്. നമ്മൾ ഓൾമോസ്റ്റ് നമുക്കറിയാം എന്താ സെൽ റെപ്രസെൻറ്റേഷൻ ആനോഡ് ആയിരിക്കും ലെഫ്റ്റ് സൈഡിൽ, കാഥോഡ് ആയിരിക്കും റൈറ്റ് സൈഡിൽ. ദാറ്റ്സ് വൈ കാഥോഡിൻ്റെ വാല്യൂ കൂടുതലായിരിക്കും. ദാറ്റ്സ് വൈ ഇ റൈറ്റ് മൈനസ് ഇ ലെഫ്റ്റ് ഓർ ഇ കാഥോഡ് മൈനസ് ഇ ആനോഡ്. So the same case in standard electrode potential. The electrode potential measured under standard conditions at 1 atm pressure and 1 molar relative to standard hydrogen electrode is known as standard electrode potential. And the standard electrode potential of a metal is measured by coupling it with standard hydrogen electrode. When the metal dipped in 1 molar solution of metal ion is contact with the She through a voltmeter, the potential difference between these electrodes are indicated by voltmeter. Since the potential of She is taken as 0, the electrode potential of other electrode can be found by relation. എന്ന് പറഞ്ഞ് വേറെ ഒന്നുമില്ല. ഈ ഇതിന് മുമ്പ് നമ്മൾ പഠിച്ച ഇലക്ട്രോഡ് പൊട്ടൻഷ്യൽ അറ്റ് സ്റ്റാൻഡേർഡ് കണ്ടീഷൻ is known as electrode standard potential. Thank you. That's for today's class. This is just a video only. It's a quick review of the topics up to this. Please go on through that. Okay. If you have any doubt in these topics, just comment